Today we're going to start looking at Chapter 5, and the first thing we're going to do is review some angle terminology. So the first thing we're going to look at is a ray. A ray has an endpoint and goes off infinitely in one direction. An angle consists of two rays joined together with their endpoints at the same spot. So here are two rays joined together. We can call this spot where they meet the vertex of the angle. And we always show the direction at which the angle has been made. So angles are always produced by the idea of rotating through that vertex, through that central angle. And the Greek letter theta is often used to denote angles. So theta. We also use the other Greek letters like alpha, and we'll sometimes use beta and others as well. So you'll see them come up, but theta is the most common one. So this is a point along ray, this initial ray here, and we'll call that point A. And this is the initial ray because it's where the angle has started. Okay, notice the direction of the arrow, and then this is the terminal arm or the terminal side or the terminal ray of the angle, and we'll call that point that's on that ray, we'll call that point C. So this is angle ABC. Okay, and we can say that its value, that angle ABC is equal to theta. Okay, so now we're reviewed a little bit of that. Let's look at angles in standard position. And by standard position, we mean angles that are placed on the Cartesian plane. And we have a few rules for doing that. And these are the rules. The vertex is always at the origin or at point 0, 0 on the Cartesian plane. The initial ray of the angle is always along the positive x-axis. And if the direction of rotation is counterclockwise, then it's a positive angle, and if the rotation is clockwise, it's a negative angle. So I'll first show a positive angle, so my terminal arm is here. We always show that rotation, that arrow of rotation. So here we have angle alpha, and its terminal arm is in quadrant 2. Remember from earlier in the previous course that the quadrants are numbered 1, 2, 3, and 4, and we typically use Roman numerals to denote those. Okay, so that's a positive angle, alpha, and I'll just demonstrate a negative angle as well. So there's y-axis, here's the x-axis. The initial ray is still along the positive x-axis, but the rotation is clockwise instead of counterclockwise. So these angles are close to each other in where their terminal arm is. We'll call this one angle beta, but it's a negative angle, okay? Only because of the rotation being clockwise instead of counterclockwise. Okay, some more terminology. Typically, in the past, you've measured your angles in degrees, and however, you would have used degrees and maybe decimals of degrees. A full rotation, so a full rotation of a circle or about the Cartesian plane is 360 degrees. So for instance, if here's the Cartesian plane and here's my initial ray, if I go all the way around and end up in the same spot, I've got I've gone through 360 degrees. It's the ancient Babylonians who decided that there should be 360 degrees in a full rotation. And there's lots of reasons that they chose that number. And one of them is that it's a very convenient number because it can be split evenly in so many ways. So 1 degree is 1/360th of a rotation. So let's look at some definitions of angles. When we have an angle that's between 0 and 90 degrees, we call that an acute angle. When we have an angle that's exactly 90 degrees, and it's always denoted with that square in it, it's exactly 1/4 of a rotation, and we call that a right angle. And we also use the terms perpendicular, that these two rays or two line segments or lines are perpendicular to each other. Okay, so that's a word that's often used with right angles. Okay, and down below that, we've got an angle that's between 90 and 180 degrees, and that is called an obtuse angle. And then we also have an angle here that is at exactly 180 degrees, so it's gone half of a rotation around, and it is called a straight angle. Okay. Now, you're used to measuring degrees as either a whole number or with a decimal, but the actual correct method or historical method of measuring degrees is to split the fractions instead of tenths and hundredths like we would with a decimal, is to split them into 60ths, which gives us minutes and seconds. So a minute, and this is the symbol used for a minute. It's an apostrophe if you were to type it. So 1 minute is 1/60th of a degree. And a second, and we use quotation mark symbol for that, 1 second is 1/60th of a minute. So 1/60th of a 60th would give us 1/3600th of a degree. So we would read this as 46 degrees, 32 minutes, and 18 seconds. Okay, so let's practice putting that into decimal degrees. So we know it's going to be 46 and something degrees. So we can do it like this. We can say, well, it's 46 degrees plus it's 32 of those minutes, which are 60ths, plus 18 of 18 seconds, and a second is 1/3600. And so we can do that addition on our calculator, and we end up with approximately 46.538 degrees. We can also go from decimal degrees, so here we have 36.57, and we can express that using degrees, minutes, and seconds. So if I look at that, really I can convert that 36.57, I can write it as 36 and 57/100ths degrees. But instead of hundredths, I really want 60ths. So we can think of that as a little proportion. So 57/100 is equal to what over 60? And that will give me the number of minutes. So if I rearrange that by multiplying both sides by 60, I'll get that x is equal to 34.2. So I've got 34 minutes, and I'm going to take that 0.2 and convert it to seconds. Okay, so I've got 36 degrees, 34 minutes, and now I want to turn that into seconds. So well, 0.2 minutes is equal to how many seconds? And I can set up a proportion like that, and really I'm just multiplying that 0.2 by 60, and I'll get x equals 12. When you get to this stage, you round to the nearest whole number. So we don't use decimals of seconds, and we don't break the seconds down into nanoseconds or anything smaller. So if this was not a whole number, as a result, you would round it to the nearest whole number. So that gives us 12 seconds. So that's the method for doing a manual conversion. Most calculators will give you an automatic conversion, and the button usually has DMS on it, so degrees, minutes, seconds. So check out on your calculators. The graphing calculators do have the ability built into them, but it's tricky to find, so there's a good challenge for you. But a lot of the regular scientific calculators that students typically have a degrees, minutes, seconds button on it, so that the conversion from one method to the next is very straightforward. So look for that thing on your calculator. There are no textbook questions with this lesson, but there is a page that will be uploaded with practicing doing this degree, minutes, and seconds, switching between that and decimal degrees, and classifying angles as acute, right, obtuse, or straight, and recognizing which quadrant angles will lie in when they're in standard position, just to get you ready for the next piece of this lesson.